Hello there, come back to the third session on creating a Kubernetes cluster on Azure Cloud. So with this session, you should be able to complete this practical. So yeah, let me share the screen. Yeah, it's done. So let's continue our practical with the workload deployment. Let's deploy a sample application. So this is the application we are going to take. And again, this one is from our reference, Azure. And now we are following a reference for this particular session. All right. So this is the reference I gave earlier, right? And the very first from Azure documents. So in there, this application is there. You can take a look at it. So I have, let's take a look at in a little bit of detail about the application prior to deploying it. Yeah, let's take a look at it. So this is basic deployment.yaml. So this is the application you are going to deploy. So what it does actually, let's take a look at deployment. Very first thing is it's going to do a deployment, right? And the name is this Azure Word Back. And so it is going to have labeling. That's okay, right? And for this one, it's going to fetch a container, Redis container. So it's kind of a database. It's going to deploy via that. So Redis container has been pulled. That's the image. So it will be the database. And we have, yeah, there's a resource limitation also. You can see it has given customized resources, right? CPU 100 milli CPUs, and that's the lower limit, and memory is there 128 megabytes, and the upper limit also defined, right? So there are resource requests. We will learn this more detail how to allocate resources and all on our CP below CP10 series. We have another series going on. Now this is above CP10. Now this is mid senior. The basic explanations will be done in that CP below CP10 series. That's the beginner sessions, right? So this is a CPU request. Anyway, the resource requests have been done for CPU and memory, and therefore when the pod is getting created, quality of service won't be best effort, because by default the QoS is best effort now. So it will be guaranteed and or burstable. So let's take a look at it later. And this the container port is this the Redis database connection default port. That's okay. So the purpose of this particular deployment is just to launch a Redis database, right? And then the second one, so the YAML file continues to the second session. You can see the separator here, 3 hyphens, and it's a service. So the second resource category is a service, and I think it's creating a service for our yeah, for the Redis database. So that's why it's using the port 6379, and this will go with the default service, which means the cluster IP service, right? Because it doesn't mention a service type. We have load balancer, not port and all. If the service type is not mentioned, it will take the cluster IP service type. That means it's for internal communication only. That's true because this particular service is trying to connect to the database. So that's why, right? We are a internal cluster IP service. Then the third session is again a separate is there. You can see is another deployment is taking place. This time Azure Word Front. This is Word Back earlier. Now it is Word Front. This is a kind of application, not a database. You can see number of replicas 1 here. That means by default there will be only one pod is going to appear, and labeling is there. Yeah, and again node selector. That's okay. Linux type node. We have anyway Linux. So container. So this the container is going to pull in, right? So it's a kind of a small program, right? Maybe a microservice program, right? Anyways, from sample from Azure. That's the image is going to pull, and again you can see the resource requests are being given, right? Customized resources. Yeah, it's connecting to container port 80. Yes, it will be exposed using port 80, and yeah, it's going to connect using env1 variable, right? Because there are different connection types to connect in between the workloads, right? So it need to connect to Redis database. So it is using env1 variables, and you can use DNS as well, but this is env1 variable, and the value as Azure Word Back, right? Azure Word Back is the previous application. This is Word Front, right? Word Back. is the previous application. I mean, remember where database was deployed, right? Port back. This is the previous SAM, right? That is where the database was deployed, and this payload is connected to there. That's all. And again, there's a service here, but now this service is for what? This is to expose this particular application to outside. So if you notice here, you can see the service type is specified, load balancer, right? In the previous service, I told you there's no service type here, so it will be the default type of cluster IP. But this one is a load balancer. Why is that? Because we need to access this application from outside, right? So once it's deployed, there will be external IP assigned from the cluster, and we should be able to access this particular application both front using that external IP. The load balancer service type will expose what is deployed within the cluster to outside, right? So that's what it does. That is all about that very basic explanation. It's not a big deployment, it's a very basic one, but as a starting point, it's very good to understand the things, right? So, I mean, anyone can start with this particular in Azure Cloud, right? So let's deploy it, right? I think we have the command, yeah, apply is there. So let's run kubectl apply -f. Our file is basic deployment. So let's run it. So while it's running, we can run the watch command, right? So we can run the watch command and to see how this service. Now you can see I am watching the external IP is pending at the moment, and kubectl get service Azure word front. I am watching monitoring this service because this is the one which is exposing the application outside. So now you can see after a while it assigned a public IP. So that means the deployment is done, configuration is done. So we should be able to access this particular application using this particular IP. So let's do it in a while. And again, you can see this port 80, which is bind to this particular port, right? So this is known as a node port, right? So we have to learn those things more detail later, node port, and because node port is something which making load balancer to expose the internal applications to outside. So node port, there's a separate service type called node port as well, right? And so that is a automatic port given by Kubernetes cluster, and there's a range. I think 32,000 is the max. 32,000. There's a range, right? And so, and what it says, what is available internal. So we saw our application use the internal port 80, right? We saw that the word back application. So it is being exposed to outside using this port, right? And you can access to the applications in this port as well, but we don't need to use the port since we have given the service load balancer. Using the IP right away, we can access without the port, right? But if the service is not port, yes, we have to give the port number as well, right? So this is a load balancer service type, so we can access it right away. So we can check it actually if you require. So let's take a look at the application. So right away we can just to go here. Yeah, this is one. So I will give my latest. This is the IP, right? This is 52. Okay, let's refresh it. So yeah, recent. Yeah, so this is the application. This is a sample application. So it is accessible using the IP, external IP. So cats and dogs and likewise. So once we click cats, it will count like that. So yeah, so let's get a new window, right? Take a new window. So this is what, right? So that's the same IP I just used, the external IP given 241 255. Right, so this is what I do. When I say cat, it will count 1, and when I say dog, it will count 1, and again dog, like that. So it will count, right? It's like a voting application, right? I can reset it, so it will like this. It's a very small application. So that is how the deployment is working. But let's do some experiments within what has happened now. Actually, we did the deployment, and we saw how the external IP is coming for the service. But we will dig in more details, right? just to understand. Right, so this is deployment is done, and this we monitored. Yeah, we can take a look at the service, get SVC, right? So get SVC command. Almost we have, let me break this, Control C, we break it, right? And almost we have seen the service. And now you can see this is what I mentioned earlier, right? The service that we didn't give any type, so that's a default type, cluster IP. So if you don't give any type, Kubernetes will always create a cluster IP service, which is for internal communication between the workload. So this is a Redis communication is happening there. And this is the second service, load balancer, right? And you can see the external IP. I just explained it. And this is something internal, right? Kubernetes server itself. So that is service. And yeah, we can get the ports right now. Should have created some ports, no, right? Because now two containers are running, right? So let's take a look at that one. PO, get PO. Yeah, so these are the two ports. One is for Redis, one is for no, actually Redis doesn't have that. One is for word back and one is for word front. Of course, Redis is word back, no, right? So Redis is deployed in word back application, word front application. This is word back is our application that we just access, right? So that is what, yeah. So if you go back to our basic deployment, yeah, Redis is deployed on Azure word back, right? So that is what Redis image, right? And Azure word front is our application that we just access. So you can see we have two ports for two deployments. So that is what visible here. Right, so two ports are up and running, both are up and running. So if you just watch this one, as soon as the deployment is done, you will see the intermediate state telling container creating. But now almost it is done. This is the intermediate state. So till is pull the container and starts the container, pull the image, till is pull the image and start in the container, the state will be container creating. So in that, this particular ready state, you can see it is 0. That means what? The pod is created, but the container is not up and running. So now here you can see the pod is created, container also up and running, and there is only one container. But here pod is created, still container is creating, so therefore it is 0, right? Image is pulling and trying to start, so that's why it's container creating. So for few seconds, it will be on this state depending on the size of the image, right? And now as soon as it's pulled it and run it, so it will be on running state. Other than some error comes up, I mean, error fallback or something, fall off, or there are certain errors, right? Container creation errors are there. So unless something goes wrong due to access issues or due to images not able to pull it, so likewise there can be issues, right? So let's take a look at those errors later. We can look the login also, right? And yeah, back off issues are there, so there can be errors container back off. So likewise. Okay, so at the moment it's okay, successful, and we can see kubectl get yeah, we can see the YAML file, right? So this is port. You want to see inside of this port. Port means the configuration, right? So because every port is configured using a YAML, so we can take a look at that one. Get port. Let's take a look at this one. Say -o out YAML output. Yeah. So that's what this is for that particular port, the YAML file behind for this was the configuration for the port. And you can see kind port and metadata. You can see, yeah, sure, that is the port and label is there. So most of the information we had on the deployment itself, an API version, and that's okay. That is the minimal version v1. And you can see these are some configurable option, configuration information. If you go down, let's go down further. And you can see kube controller manager operation update, that's okay, and status initialized, and okay. So let's go down further and operations. So this is the name, and namespace is default. That's true because we didn't mention a namespace for this one, so it will go for default namespace. And yes, so this is the higher version of the API because I think it's using some options. That's why it's using the higher version. And API apps v1, yeah, that is for that Redis and is calling on here. It is just version 1, but here it is using some features when the deployment is done. So that's why it's label pitch and I think selector, there are some features it was using. That's why it's using the second version here, higher version for the basic v1 version, right? That's okay. And find replica set, yeah, I mean we had only one replica, I may remember that. And here, this is the port, Redis port, and resource request, and most of the information which we had on the deployment are available. We don't have any volumes here. We didn't create any volume, right, in the deployment. Service account, this goes for default one. We didn't, no record, no complete maps. We didn't include those things here, right? Yeah, the default scheduler, that's to schedule this workload, right? So in the API, we know the architecture now. So API should hand over to the scheduler to schedule this job to the worker node. So that's why it's using the default scheduler. Yeah, the termination grace period, yes, those are default anyway, right? And for the port toleration limits, those are again default. Yeah, so and again we have the host IP. So this is deployed in number 5, right? So node number, second node, I think IP is 10 to 40.05 now. So you may remember we had 2 nodes, right? So one node IP was 5, right? So it is deployed there. And you can see the port IP. So this is, we have a port here. So this is the CIDR range. So it has started from that range, and the IP has assigned number 4, right? If you take a look at the other port as well, this IP is going to be different. So let's, and again, you can see the burstable. QoS class is burstable. That is because we did the custom resource allocation. Normally, QoS is best effort if you don't give the resource allocation, but here we have given customized resource allocation, the CPU resource and memory resource. And further, if you look at get PO, I think we can take a look at the other port as well. So in that, now this IP is port IP is 4, which is running in this particular node IP. So if you take a look at the other port, so let's take a look at the other port as well. The second port, this one, right? Let's take a look at that. And if you go down right away, yeah, you can see that port IP is number 5, right? So that's a different port, right? Because each port has a unique IP. And again, that also scheduled to the same node, right? So we have 2 nodes, but scheduler has assigned is to the same node. That's okay, because we don't have that much of workload there, right? Because there's only one application is running. And yes, so that is the port IP is a different, right? So I think you got an idea about the content in the configuration for the port using the YAML. And we can get namespaces, whole lot of namespaces using minus all namespaces here. Let me clear the screen. Minus all namespaces. So these are the default. This is default. Why? Because we have 2 ports, right? So how the ports are deployed. So these 2 ports we were just watching earlier, and it is in default namespace because we didn't create a namespace here, right? In the deployment, we didn't mention. So if you don't mention a namespace, going for the default, right? And these are for internal Kubernetes containers, right? So that is that. And yeah, if you want, we can get more details about the deployment as well. So we watch the pod and we take a look at the namespaces, port configuration, and further we can get the deployment. So we have how many deployments? There were 2, no? In our YAML file, we did 2 deployments, right? So this is one deployment and this is another one, right? And we can describe the deployment. I think, yeah, this is one, right? So let's describe one of these deployments so we can see more details of that, the replicas and all, right? Describe, deploy. Yeah, so if you go up, I think now you can see this is the what back deployment, and labels namespace is default, right? And selector is this what back. That's okay. Replicas only one. You may remember we had only one replica in the deployment, right? So desired is one, update actual also one, and rolling update and labels are there. So this label we assign while the deployment is going. That's why the selector also there. And the image is the image we pulled for this deployment, Redis image, and the resource request and the port. And so yeah, this is basic information for the deployment, and you can see normal in the events normal scaling replica set 30 minutes ago, deployment control scale up to replica only one because we requested only one. So we can do manual scaling, but let's do those things later. So auto scaling also possible with the matrix server. Again, we do it later. I think you saw the matrix server here. You can see there's a default matrix server for these managed clusters. This Azure is a managed cluster, so most of the managed clusters are having a default matrix, whereas a manual created cluster, we need to deploy a matrix server separately, right? Okay, so let's go down. I think, yeah, that is deployment. Yeah, I think that is the end of that document. And so hope you get an idea about the cluster creation and doing a deployment and getting into the configurations and deployment configuration port and those things, right? And the last thing is now we watch the application that we did earlier. We access it to the external IP load balancer via the load balance service. The last thing is cleaning off. Very easy to clean it off. Why? Because we control everything, or we store everything in a single resource group, right? You may remember initially we create the TNS resource group. So now it's just a matter of deleting the resource group with no wait. So once you do that, all the configurations will get clean off, right? Including your cluster. So just clear it like that. Otherwise, if you keep on running, it will be a cost for you, right? So let's delete it once the practical is done. So Azure is a group delete minus name. This is a resource group. Yes, no wait, press enter. So it will take 4 to 5 minutes, but this command will proceed because it is no wait, and it will give me the control. But for deletion, it will take 4 to 5 minutes, right? So yeah, so that is that. Right. So just monitor for this one 4 to 5 minutes. It will be taken off, right? All right. So I'll meet you back. I think that's the end of this series for the Azure cluster creation. I'll meet you back again. And if you like the session, you can put a subscribe. Okay. Bye bye. Have a great time.